To solve this question, we can draw the image of the patient as well as the chart. Okay, the patient is 2 meters in front of the mirror. So the image of the patient will be formed 2 meters behind the mirror. And the chart is formed 2 plus 3, 5 meters in front of the mirror. So the image of the chart, it will be formed 5 meters behind the mirror. So that will be another 3 meters away. Okay, so we are asked how far from the patient is the image of the chart. Okay, the image of the chart is here and the patient is here. So there's a distance of 2 meters plus 2 meters plus 3 meters. So total 7 meters away. We are asked which of the following in the EM spectrum has the shortest wavelength. Okay, instead of just memorizing, right, we can use a mnemonic to help us. Okay, we have Romeo's mother is very ugly, exclaim grandma. Okay, so R stands for radio wave, M will be microwaves, I infrared, V visible light, U ultraviolet, X ray, G gamma ray. So we need to know the order of the frequency and wavelength. So let this be the frequency and wavelength. Okay, just need to memorize that gamma ray has the highest frequency because gamma ray is the most dangerous ray here. So this will be the highest, and of course radio wave will be the lowest frequency. So it goes like this. And gamma ray, since it has the highest frequency, it must have the lowest wavelength. So radio wave will have the highest wavelength. So it goes like this. So with this, we can easily conclude that the EM wave with the shortest wavelength, it has to be gamma ray, A. We have a displacement time graph of a sound wave. Okay, so we are asked, what if the sound is being played more loudly? What will happen to the displacement time graph? Okay, so we can use the mnemonic. Funny people are lame. Okay, funny means frequency is related to the pitch, and amplitude is related to the loudness. Okay, so in this case there is no change in the pitch, the frequency must stay the same. So if frequency stays the same, every 4 seconds I should see one complete wave. Okay, whereas amplitude is related to loudness. Now the sound is being played more loudly, so I'm expecting a higher amplitude. So the resultant displacement graph should look something like this. Okay, increase in amplitude but no change in the frequency. Okay, looking at the option, the answer should be D. Okay, we are given the power and the voltage rating of this electric lamp. So we can use the power is equal to VI formula to find out what is the current that the electric lamp is using. So I is equal to P over V, that will be 48 divided by 12. We have 4 ampere. Okay, we're going to find out how much charge passes through the lamp in 2 seconds. We can use the formula. I is equal to Q over T. So Q is equal to IT. I is for time taken is 2 seconds. So we know that there is 8 coulomb of charges that flows through. Answer D. Okay, when contact M is at X, okay, this is the circuit that we are looking at. That means we only have a 10 ohm resistor in series with the battery and the ammeter. So the ammeter reading reads 0.6 ampere. So we can find out what is the voltage of the cell. We can use the formula V is equal to IR. That will be 0.6 times 10. We have 6 volt. Okay, so now we know that the battery is 6 volt. Okay, so now we shift the contact M to position Y. Okay, so let me erase this. Okay, when M is at Y, we have a series circuit. Okay, that has 10 ohm and 20 ohm resistor in series. Okay, so now the total resistance will be 10 plus 20 is equal to 30 ohms. Okay, and what is the ammeter reading? Okay, of course it won't be 0.6, we have to calculate. Okay, this I, it will be equal to V over R. The voltage here is 6 volt and the resistance here is 30 ohm. So we'll get 0.2 ampere. Okay, the answer should be B.